Hello everyone. So today in this video I'm going to show you how to balance the chemical equation. So in the previous video I explained how to count the total number of atoms. It is a very important step before we start balancing of chemical reaction. I will show you a few examples. So here is my first example. Aluminum plus HCl, aluminum chloride. One thing is very important when we balance the chemical reaction, we don't change the subscript. Only coefficient is the main key part for balancing the chemical reaction. If you change the subscript, it means you are changing the identity. So first you need to make two columns, left and right. So left for the reactants, right for the products. Then you will count the total atoms in each column. We'll start with the reactant. Aluminum 1, hydrogen 1, chlorine 1. Product side, aluminum 1, hydrogen 2, chlorine 3. So we can see aluminum is balanced, hydrogen is not balanced, and chlorine is not balanced. You can pick any, but for a easy way, better start balancing the big formulas first and leave the elemental form at the very end. Sometime what happen when we balance the big formulas, automatically these elemental forms are balanced, so we don't have to uh, erase and keep changing the coefficient. So let's see. We'll first balance the chlorine. So you have a 3 on the right hand side, you have a 1 on left hand side. So I need to make it 3. So what to do? Like I said, it's the only coefficient we are changing. We are not touching the subscript. So here we go. My chlorine is balanced, but I changed the number of hydrogen too. Now I have hydrogen 3 on the left hand side, hydrogen 2 on the right hand side. So when you have this type of situation, odd and even, so get a common number, least common multiplier. So multiply these two numbers with each other and get a common. So it means I need to make 6 on both the sides. Okay, here we go. So you can pick any side. So here we go. So how I'm gonna change this hydrogen 6 if I use the coefficient 3. So 3 times 2 is 6. Now let's change the hydrogen on the left hand side. Here we go. If you want to make hydrogen 6, you have to use the coefficient 6. So my hydrogen is balanced, but I changed the chlorine number again. So now I need a 6 here, but you have a 3 on the right hand side. It means you need to make it 6. So what to do? You need to use the coefficient here. So if you use the coefficient 2, so 2 multiplied 3 is 6. But I changed the aluminum number 2. So now you have a 2. So you need to make it 2 on the left hand side. How will you change this aluminum to 2? If you use the coefficient. Last, check the table. Aluminum 2, 2. Yes. Hydrogen 6, 6. Yes. Chlorine 6, 6. Yes. So let's go to the next example. So I will pick the combustion example. Usually kids are having trouble balancing the combustion of hydrocarbon. So here we go. So let's pick C10 at 22. Leave some space for the coefficient. Oxygen, it's a combustion, so it means you are using oxygen as one of the reactant. So combustion reaction for hydrocarbons. Products are always carbon dioxide and water. Here we go. So same thing. Make two columns. Left side your reactants, left side of the arrow, right side of the arrow your products. So it's clear we have three different types of atoms: carbon, hydrogen, oxygen. Same on the right side: carbon, hydrogen and oxygen. How many carbon you have on the left side? 10. Hydrogen 22, oxygen 2. Right side: carbon 1, hydrogen 2, oxygen 2 here, 1 here. 2 plus 1 is 3. So it's clear nothing is balanced. So like I said, start balancing with the big formula, leave the elemental form for the last step. So let's start with the carbon. So you have 10 on the left side, you have 1 on the right side. So I want to make it 10. It means I need to use my coefficient 10. Here we go. So I make my carbon 10, but I change the oxygen number 2. So now 10 times 2 is 20. 20 plus 1 is 21. Let's go with the hydrogen. So you have 22 on the left side, you have 2 on the right side, you want to make it 22. So what to do? So if you multiply with the coefficient 11, 11 times 2 is 22, but I change my oxygen number again. 10 times 2 is 20, and 20 plus 11 is 31. So now carbon balance, hydrogen balance, oxygen is not balanced. You can see it's an odd and even situation. So what to do? Least common multiplier. Multiply these two numbers with each other and find a common number. It means I need 62 on both the sides. I want to make 62 here, and I want to make 62 on the right hand side too. So how to make it 62? If I use the coefficient 31, 31 times 2 is 62. Here we go. You already have half of the oxygen on the right hand side, so you need another half. So what to do? Because your oxygen is in two formulas, so I will say double these coefficient. So in place of a 10, double will be 20. So use 20. Here we go. And in place of your 11, double it. So if you use 20 to 11, double of 11 is 22, then your hydrogen will be 44. So I need to use 22. Okay. So if you use 22, here we go. Now let's add your oxygen. 20 times 2 is 40. 40 plus 22 is 62. Here we go. So our oxygen is balanced, but we change something else too. Now you have a carbon 20 on the right side, you have 10 on the left side, so you need to make it 20. Also, you have 44 hydrogen on the right side, you have half on the left side, you need to make it 44 too. So what to do? How about if we use the coefficient 2? If you multiply this formula with the 2, you can see 2 times 10 is 20 and 2 times 22 is 44. And last, just check your table. Carbon 20, hydrogen 44, oxygen 60. So this equation is balanced. Next, I'm going to show you last example where you have a polyatomic ion, means where you have more than one non-metal in the formula. So here we go. Let's say we have this chemical reaction, sodium phosphate, parenthesis for sure, and you have calcium chloride, and you form calcium phosphate with the 2, and you have sodium chloride. So I have to write sodium chloride at the bottom. I don't have a space. Okay, same thing. Make 2 columns, left and right. Left side for the reactants, right side for the products. So what's different here? So how to check if you have polyatomic ion? So you have to pay attention that group of non-metal, if they stay together, in the product side, it means that's your polyatomic ion. So I will say balance that polyatomic ion as a single unit. Don't try to balance it separately in different atoms. So it's clear that PO4 on the left hand side, you have a PO4 on the right hand side. So it means you will count it as PO4, not phosphorus and oxygen separately. Then it's very easy to balance it. So we'll see, we have sodium 3 on the left side, you have a sodium 1 on the right side. Next you have a PO4 unit 1 on the left side, PO4 unit 2 on the product side. Here we go. Then you have calcium 1 on the product side, and you have a calcium 1 on the reactant side and calcium 3 on the product side. Then you have a chlorine 2 on the reactant side and chlorine 1 on the product side. So it's clear nothing is balanced. So, and all are big formula, you can pick any. So let's start balancing with the sodium. You have sodium 3 on the reactant side, sodium 1 on the product side, you need to make it 3. It means if you use the coefficient 3, you make sodium 3, but you change the chlorine number also. Now you have chlorine 3. Okay, let's go with the calcium. You have calcium 3. You can pick any. You have calcium 3 on the product side, calcium 1 on the reactant side. You need to make it 3. So if I use the coefficient 3, so my calcium is 3, but I change the chlorine number also. 3 times 2 is 6. And you have 3 chlorine on the right hand side. Okay, so here we go. So let's pick your phosphate, PO4. So you have PO4 2 on the product side, you have 1, you want to make it 2. So what to do? If you use the coefficient 2, PO4 is balanced, but you change the sodium number also. So now you need sodium 6 on the left hand side. You have 6 on left, you need 6 on the product side too. So for that, it means I need to change my coefficient. And if I use 6 coefficient, sodium is balanced, I change my chlorine number 2. Now I have a chlorine 6. So let's check our table one last time. Sodium 6 left, right. Phosphate 2 left, phosphate 2 right side. Calcium 3 left side, calcium 3 on the right side. Chlorine 6 left, chlorine 6 right. So what's the ratio? If I have to write the ratio of balance equation, sometime in the exams or quizzes, answer options are in terms of their coefficient. So our ratio is 2, 2, 3, 2. If there is no number, it means 1. Make sure there is no such word 0 in chemistry. If there is no number, then it's a 1. So this is our ratio. So I hope this guide will help you how to balance your chemical reaction in very short time. Thank you, and see you next week.